LCP subparts are a great way to understand larger contentful paint issues on your website and figure out what you need to do to fix them. In this video, I'm going to show what the larger contentful paint subparts are, how they show up in Google's CrUX report, and then we're going to look at a few examples of each of the subparts and how you can fix them. The first subpart is time to first byte, which tells you how long your server takes to generate the HTML response. After that, for images, comes the load delay time. So that tells you how long it takes for the browser to discover the LCP image on the page. Once the browser knows that it needs to load the image, it's going to take a certain amount of time to actually download the image completely. So that is the load duration subpart. And finally, there might be reasons why the browser can't display the image right away after it's been downloaded. So that is called the render delay. The data that you're seeing right now is coming from a debug by lab test, but we can also go into the Web Vitals tab to see the Google Chrome user experience report data there directly. So Google recently started reporting each of these subparts directly in the CrUX data. And as usual for CrUX, we are seeing the 75th percentile values. The other thing that Google started reporting is the larger contentful paint resource type. So that tells you whether for actual visitors on your website, is the LCP element an image or is it a text element? It's important to note that in the CrUX data, the subparts only apply to image elements on the page. So for text, where the load delay and load duration components are going to be 0, those are not going to be included in the LCP image analysis data. Now let's look at an example with a high largest contentful paint component. I can click on the largest contentful paint metric title and then scroll down to the subparts view. I can expand the waterfall, and now I can see a bit more clearly what's happening. The time to first byte isn't too bad, but then after that, it takes a really long time for the browser to actually discover the LCP image. And we can also see why that is, because the LCP image is actually loaded indirectly via a JavaScript file. And this JavaScript file is loaded asynchronously, which means it's going to have a low priority because it is not render blocking. And then also, we can see there's a long task on the main thread after that. So all of that code has to download and then run. And only after that does the browser know, oh, I need to download this image in order to display it. And then once the browser knows that, downloading the image and displaying it does not actually take that long. That was our first example. Now let's look at another one where it's a long load duration component. Again, I expand the metric and I look at the breakdown, and usually debugging load duration is pretty simple. Generally, it means that you just have a really big image file that takes a long time to download. So here we can see that the image is almost 2 megabytes large, and that explains why it takes so long to download. If you see a lot of load delay, you might also want to check if there are competing resources on the page that are also using up bandwidth at the same time. For example, the image might load ever so slightly faster if this other image wasn't loading at the same time. However, overall on this page, I don't think there's a lot of delay that comes from downloading competing image, but downloading the image takes a long time because the image is so large. Next, let's look at an example of render delay. So I open the large contentful paint metric, and we can see that the image is loading really quickly, but then it takes a really long time to actually display to the user. Now debug there makes it really easy to debug these things, because we can already see that CSS body hiding may be delaying the large contentful paint. So what's happening here is that the page is using an A/B testing tool that's hiding all the page content until all the A/B tests are loaded, and that's why there is a delay in rendering the image. While the CrUX subpart breakdown only looks at images, it's worth noting that if you see a render delay for a text element, that usually means something else. So it's not like CSS hiding the content or some other additional delay like that. So instead, this would be caused by render blocking resources. So here in this request waterfall, we can see that the TTFB is pretty good. And then after that, we just have a bunch of CSS files that have to load. And once all of those are loaded, that's kind of when the page content is ready to render on the page. Now the final example we're going to look at is pretty straightforward. This is a poor TTFB score. I'm expanding this again, and you can see it just takes almost 1.5 seconds to actually get the HTML response from the server. So because of that, the browser can't really do much else in the meantime, and that's kind of what's causing the high TTFB subpart in this example. If you want to test subparts on your own website, you can go to debugbear.com/test and enter your website URL there.